All right, so the title of your notes is going to be Evaluating Inverse Trig Functions. Evaluating inverse trig functions. So when we evaluate inverse trig functions, we are only allowed to look at specific quadrants in the unit circle, and students always ask me why we're only allowed to look at those ones. That's what the video notes from last night were talking about, is that for it to be a function, it has to pass the vertical line test, and so you can't use a curve that goes back and forth like this and think that that's going to pass the vertical line test. And so what you do is you limit yourself to only a part of it, and you say, okay, my answers have to be on that part of it. Okay, that's basically what the video last night was talking about, is why we have to limit inverse trig functions, because we have to make them functions. Okay, the practical application of that is what we're going to talk about today, like what we actually do in math class as a result of what we saw last night. Okay, so go ahead and draw this part on your paper. Of the 4 quadrants, when we are given a cos inverse problem, we only get to look in quadrants 1 and 2. So cos inverse problems always come from quadrants 1 and 2. You do not even look at quadrant 3 and 4 when you're doing those problems. Okay. Sine and tan inverse only come from quadrants 1 and 4. You don't get to use quadrant 2 or 3, okay? And then we're going to write a little note to ourselves. For quadrant 4, we only get to use the negative version of the angle, okay? Only use the negative version of the angle, okay? And the reason that we can only use these quadrants is because cos inverse has a domain of 0 to pi. That's what was in your packet of notes from last night. And sine and tan inverse have a domain of negative pi halves to positive pi halves. And that was also in your video from last night. Okay, so the practical application of that video from last night was cos can only use quadrants 1 and 2, sine and tan can only use quadrants 1 and 4, and angles in quadrant 4 have to be written as the negative version of the angle. Okay, so if you don't have your unit circle out, go ahead and grab it. We're going to be using it to do some problems for today. As soon as everyone starts working, I'll probably go check them and then give them back to you. Yeah, I gotcha. So what I like to do on my unit circle for today's assignment is I typically rewrite some of these angles as the negative version so I cannot get confused, okay? So if this up here is positive pi over 6, then that means that this one right here is negative pi over 6, because it's the same amount, you're just going backwards, okay? So right over here I'm going to write negative pi over 6. If up here is positive pi over 4, then right down here would be negative pi over 4. And then this one would be negative pi over 3. And this one would be negative pi over 2. So we are going to use those quadrants specifically when we're looking for inverse trig functions, okay? On my unit circle, since the unit circle has kind of been like a cheat sheet of sorts for certain information, I'm going to go ahead and draw what I know about inverse trig functions. So I'm going to go ahead and draw this part that quadrant 1 and 2 is the only place I get to look for cos inverse. And I'm going to go ahead and draw this part where sine inverse and tan inverse have to come from quadrants 1 and 4. All right, so if we go back to our notes, You will see problems that say sine inverse. And sine inverse is the same thing as arc sine. So they could say sine inverse, they could say arc sine, they're technically the same thing, okay? Cos inverse is the same thing as arc cos. Tan inverse is the same thing as arc tan. Just like before, if we have a problem that is written as cosecant, we can flip it and turn it into sine, okay? So if you had cosecant inverse of 3 over 1, then you could say that that's exactly the same thing as sine inverse of 1 over 3. So just like before, we can still switch the trig function we're talking about by flipping it if we want it to be one of the ones that we are more comfortable with. Okay? All right, so we're going to do a couple of examples. We're going to do sine inverse of -1/2. So what this is saying is we're going to take our unit circle out, and we are only going to look at quadrants 1 and 4, and we are going to try to locate the angle where the y-coordinate is -1/2. Okay, so take out your quadrant, or your unit circle, cover up quadrant 2 and 3, you're looking at only 1 and 4, and you're looking for a y-coordinate of -1/2. Where does that happen? At 11 pi 6, which we're going to call negative pi over 6 for today. Okay? So we're going to write down this equals negative pi over 6. Okay? Here's another example. We'll do cos of root 3 over 2. Cos of root 3 over 2. So on your unit circle, you're going to cover up quadrants 3 and 4. And you're going to look to see where there is an x value of root 3 over 2. Okay? So we cover up 3 and 4, and I'm looking for an x value of root 3 over 2. What's the radian angle? It's pi over 6, right? The x coordinate of root 3 over 2. Okay? So we're going to say that equals pi over 6. All right, if I look for a problem that is sorry, that was cos inverse. I missed the inverse. Sorry, that was my bad. Okay. Next, we're going to look for arctan of square root 3. These ones are a little bit more difficult because with tangent, you have to think about what divided to make that happen. Okay? So with tangent, I'm going to think y divided by x simplified and became this answer, okay? So I'm looking, since it's tan inverse, I'm looking only in quadrant 1 and 4. I need to find a y divided by x that simplifies to be square root of 3, okay? Since I don't have a negative in my problem, I know I'm not looking in quadrant 4. So I can look in quadrant 1. I'm looking for a y divided by x that becomes square root 3. I know it's not this one, I know it's not that one, and I know it's not this one. So between the two leftovers, which one would have a y divided by x that becomes just root 3? That'd be this one right here, right? So if we ignore the 2's because they cancel out, y divided by x would be root 3 divided by 1, which would simplify to just be root 3, okay? So I'm going to say that that's pi thirds. All right, here is another example. I'm going to do cosecant inverse of 2 root 3 over 3. Does that number, the way that it looks right now, show up on your unit circle? No. So I probably don't want the cosecant inverse version. I probably want the sine inverse version. Okay? How do I find sine inverse instead of cosecant inverse? I take the fraction and I flip it. Okay? So I'm going to flip this fraction. That's 3 over 2 times the square root of 3. And how do I fix that fraction so the square root is not on the bottom? So square root of 3 on top, square root of 3 on bottom. And so on the top we have 3 times the square root of 3. On the bottom we have 2. And then what is root 3 times root 3? It's just 3. So we have 2 times 3, which is 6. Okay? Can we simplify that anymore? Yeah, what happens with the 3 over 6? 1/2, right? So the 3 becomes a 1, the 6 becomes a 2. So this is really root 3 over 2. So what I'm going to look for on my unit circle is I'm going to say I'm really solving the problem sine inverse is root 3 over 2. And so on my unit circle, I'm going to look in quadrant 1 or 4, and I'm going to look for a y coordinate that is positive root 3 over 2. Pi thirds. So that means that I can go back up to this problem and say, okay, this was actually pi thirds. Okay. How are you feeling with this information? Is there part of it that feels hard to you guys? What part feels difficult about it? Finding the number on there. So I think the ones here that are easy are the cos and sine. Look for the x-coordinate, look for the y-coordinate. That's pretty straightforward. The ones that are more difficult, especially, are the tan, because you're just not going to see it on there, right? You have to think about simplifying it. So let's do some more tangent ones. So if I try tan inverse of -1, I have to look in quadrants 1 and 4. For a y divided by x that would simplify to be -1. Okay? So looking in quadrant 1 and 4, which quadrant makes more sense to look in if our answer has to be negative? Quadrant 4. Okay, so we're looking in quadrant 4, and we know that the two numbers, when they are divided, they become a 1. So which one would make sense for them to divide and become a 1? It'd have to be this one, right? Because they have to be the same number. That's how they divide to be 1, is they have to be the same. So we're going to say the answer is negative pi over 4. All right, let's do secant inverse, and let's do negative square root 2. Secant inverse negative square root 2. So we are not going to find that one very easily, right? What should we do instead? We're going to think of it as a fraction, and we're going to flip the fraction, because then we can just look for cos inverse, okay? So if I think of this over as a fraction, it's over 1, so what do I get when I flip it? 1 over square root of 2, and there's a negative in the front. And how do I fix that? Multiply by square root 2. And what do I get? Square root 2 over 2, and there was a negative with the problem there, so there's still a negative with the problem. So instead of looking at secant inverse of negative root 2, I'm going to think of cos inverse of negative root 2 over 2. That's what I'm going to do instead. So on my unit circle, I'm looking at quadrant 1 or 2, and I'm looking for an x-coordinate of negative root 2 over 2. Second quadrant, and what would the angle be? 3 pi over 4. Okay, so then I'm going to go back up here, and I'm going to say, okay, my answer was 3 pi over 4. All right, let's try another one. Cotangent inverse of 0. Cotangent inverse of 0. Now this one, if you want to just leave it as cotangent, in my opinion, cotangent and tangent are about the same because it's just x divided by y instead of y divided by x. So here, cotangent inverse would still be in quadrants 1 and 4 because cotangent is related to tangent. So we're still looking in quadrants 1 and 4. And we're looking for something where the x value divided by the y value would equal 0. Yeah, so this one is actually going to have two answers that we could possibly have. Yeah, negative pi over 2 or pi over 2, okay? So I'm going to say negative pi over 2 or pi over 2. All right, let's look for arc sine of negative, arc sine inverse, that's not a thing. Just arc sine. Arc sine of negative 1. Arc sine of negative 1. So we're looking in quadrant 1 or 4. We're looking for a y coordinate of negative 1. Negative pi halves. So we have a y coordinate of negative 1 down here, and that is negative pi halves. Okay. How are we feeling about those? If we wanted to see another example, what type would we specifically want to see? Maybe the tangent ones, maybe the secant ones, or the cosecant ones. Secant? Yeah? Okay. So let's do arc secant, and this time we'll do 2. Arc secant of 2. That would be the inverse of cos, right? We could switch it to that. So I'm going to think of this as 2 over 1. And then what am I going to write? 1/2. Do you guys like inverse or do you want to say arc cos? Cos inverse or arc cos? How should we write it? Cos inverse? Okay. So I'm going to say it's going to be the exact same answer as cos inverse of 1/2. And so we're looking in quadrant 1 or 2 for an x coordinate that is 1/2. Yeah, pi thirds. So this is pi thirds, which means that this answer must have been pi thirds. Okay. All right, last one, and then I'll let you guys practice. We're going to do arctan of negative root 3 over 3. Arctan of negative root 3 over 3. So what quadrants are we looking at? 1 and 4. And we're looking for a y value that simplifies, or a y divided by x that simplifies to be negative root 3 over 3. So since it has a negative, I'm only in quadrant 4. It's not going to be this one or this one. It's not going to be this one. So between those two, which one would have a y divided by x that would become root 3 over 3? Yeah, it'd have to be this one, right? Because this one, if you did y divided by x, it would just be negative root 3 over 1. So this one would be negative 1 over root 3, and it would have to get fixed. Does that make sense? Okay, so the answer for that is negative pi 6. All right. Okay, so our next example, these are going to be like the first couple problems on the back side of the page. So if you look there, you're going to see that they have what's called a composition, where they have 2. So this first example is cotangent of sine inverse of 1/2. So what you're going to do first is you're going to ignore the outside. You're only going to look at the inside part. So sine inverse of 1/2 means that I'm looking at my unit circle in quadrant 1 or 4, and I'm looking for where there is a y coordinate. I'm looking for where there is a y coordinate of 1/2, which is where? Pi 6. So this answer right here is pi over 6. All right? And then what I'm going to do is I'm going to bring the outside back into the problem, and I'm going to say that my job now is to find cotangent of pi over 6. So cotangent is x divided by y, right? Which would be root 3 over 2 divided by 1/2. And we know that the 2's always cancel. And so what is this going to equal? Root 3 over 1 is just root 3. So this equals root 3. Okay? So instead of it being a one-part problem, it was a two-part problem. We did the inside first, and then we did the outside. Okay? It's the same idea as PEMDAS. Please excuse my dear Aunt Sally. Remember, the P of PEMDAS is the parentheses, and that tells you to do the inside of the problem first. We're doing the exact same thing here. We're doing the inside first, and then we get to do the outside. So let's try another one. For this one, we're going to do secant of arctan of 1. Secant of arctan of 1. So I'm going to start with the inside. The inside says arctan of 1. I'm going to start with the inside. So I'm looking in quadrant 1 or 4, where the y value divided by the x value simplifies to become 1. Looking in quadrant 1 or 2, or sorry, 1 or 4, pi fourths. So I'm going to say the inside was pi fourths. And now I need to find secant of pi fourths. So it's a two-step problem. Inside, then outside. So secant of pi fourths would be what? Say it again. So secant is the flipped version of cos. So we're going to look at the cos value. We're going to flip it. 2 over square root 2. And if we simplify that, 2 over square root 2 needs to multiply by root 2 over root 2. And on the top I get 2 times root 2. On the bottom I get, those cancel. And so this is just square root 2, and so the original problem just equals square root 2. Okay? All right. So for homework tonight, you're going to finish that first worksheet we started on as a warm-up. You are going to finish the 3 problems, 20, 21, and 22 that are similar to this. And then what I'm going to do is I'm going to make a video on some of the problems, 23, 24, 25, something like that, and then I'm going to have you finish the worksheet. Okay? So the question that was asked a lot is like, what of the stuff we learned today is going to show up on the quiz? The easy problems. If I say sine inverse of 1/2, you should not have an issue looking at your unit circle and being like, oh, that's pi 6. Okay? That's an easy question. Okay? Cosecant of 2 root 3 over 3, probably not going to show up on the quiz tomorrow. Okay? But cosine of -1, that's an easy question. Quadrant 1 or 4, I look for an x coordinate of -1. Okay? I should be able to ask for tan inverse of 1 because we know that it's just root 2 over 2 divided by root 2 over 2. Okay? So the ones that we're a little bit more comfortable with are fair game. Okay? Unit circle, yeah.